thank you so much for all the teams who submitted their awesome projects. There are total 24 submissions. Little heads up here is that we don't know how many of these teams are here or how many of them are online, even though we said at least one person should be here and do the presentation. So I will call each team in the order of the Excel list I shared in the Telegram chat, and 5 seconds after I named this team, if you don't show up, we'll go to the next team. Okay, so let's start the presentation. Better? Okay. So we'll start the presentation, and the duration is 5 minutes. And the first team's name is CosmWasm Lottery, and they built on Neutron Track. Okay, so here you go. Do you need one mic?
Yeah, just one.
One. We are here for the questions.
Moral support. Cool. All right. Hey, everyone. I'm Lauren. This is Tasneem. This is Kais. We are CosmWasm. Tasneem and I are from Informal Systems, and Kais from Noise. So yeah, our project is a demonstration in using formal methods, and it aims to demonstrate a proof of concept in automatic code generation for correct by construction CosmWasm contracts. So we're showcasing the use of this tool for a cross-chain game we developed on Neutron. We've modeled, verified, and instantiated a lottery game that leverages Noise Network's random generation callback to choose a winner. So yeah, the lottery manager is a contract that we deployed on Neutron and instantiated with a reference to the Noise proxy contract, also deployed on Neutron. And when a new lottery is created, it sends a message to the Noise proxy to book randomness after the lottery expiration time that we set. And this queues a job on the Noise network to release a randomly generated seed a few seconds after the lottery expiration in the form of a callback to the lottery contract. And the lottery contract defines an entry point for the Noise callback, Noise receive. And that is effectively a proxy for the lottery payout. And when this callback executes, it picks a random winner from the list of depositors and pays out 50% of the balance to the winner and 50% to the community pool to hopefully fund public goods. So I think we can do the demo after, but just an overview. So development began with a formal specification of the intended behavior of the game contract, so we could correctly express, structure, and communicate desired functionalities. And the specified model enables running simulations, test generation, and immediate identification and verification of vulnerabilities. So long-term, the goal would be to further develop Quint to automatically generate a contract that would be immediately ready for deployment, and this would enable Neutron to provide a high-quality environment for developers to securely build apps and offering a competitive advantage compared to other smart contracting platforms. For the purpose of this demo, we wrote a proof of concept of the parser that takes this model definition in Quint and then generates the contract state definition in Rust. And in the future, the Quint team could develop a DSL like plug-in or annotations for CosmWasm to bring this vision to fruition. So without further ado, we'll try to run through the demo super quick. So this is the lottery demo. And I will try to run this on 2x. So do you want to talk through it?
So here we started the lottery, so it's instantiation of some games. One game is one lottery, and then here we can see that these are the bank accounts of two participants. These are the two participants of the lottery. And then this is, you can see it's still not expired, which means the lottery is still going. People could still participate. That's the balance of the lottery. So 3 people played with, so 3 people put the same balance. Now this is the relayer. This is pretty much asking for randomness from noise. And then as soon as the lottery is done, then noise sends the call back, and that would actually set the winner and also distributes. Yeah, you see here there's a winner that distributes the reward. Half of it goes to the winner, and the other half goes to the community pool. So this shows how the bank balance of the winner went up because, well, they won. That's pretty much it.
Cool. I think maybe we go quickly also then through the, yeah, we go through Quint super quick.
So for the lottery smart contract, we have developed a model in Quint. So the model is up. So we are able to, there is a simulator tool for debugging using Ripple. So you can see here, for example, that we have initiated the contract. So, and we can see that in the state there is nothing here. The lottos are empty. So here, for example, we want to create a new lotto that takes 10 tokens for 5 amount of time, and we can see that in the map of lottos we have a new one, and then we can create another one with different amount of token to deposit and time constraint. Here, Alice wants to deposit 10 tokens in the first lottery, so you can see that the set of depositors has been updated with Alice, and then Bob also wants to participate, so you can see the state of the system that now we have 2 depositors, Alice and Bob. Then at the end, the admin wants to execute the winner, and we can see here that Alice has won, and in the Quint it has been indeterministically chosen, and in the implementation it's noise randomness that is taken into account. So this was Ripple for debugging. It allows me to debug the contract and try different actions, but we can also define some invariant checks. Here, for example, we check whether all the deposits are positive, and we run the simulator, and we can see here that a violation has been found, and it gave a scenario where we can see that the deposits are negative. So what it makes is it runs multiple simulations, trying to verify if the invariance, the property holds or not. And as soon as he finds a scenario, so all the data is randomized, as soon as he finds a scenario, he picks it. And then for the other one, we wanted to check whether the property that the administrator of the lotto shouldn't be a winner, and it passed. So it showcased how we can, with the model, verify all the properties and generate from there a smart contract that is correct by construction. This is what QuintWasm is intended to be.
Yeah, it's super quick. This is the on-the-fly generation. We run the parser. And then we see we have an output. State definition. That's it. Thank you.
So we're here if you have any questions.
Thank you. So next team, Neutron Shield, who build on Neutron. Please come to the stage and do your presentation. You can connect your laptop there. How many minutes were they did? 8. Okay. So Marcus?
Yeah, Shane is also coming. I think he's on the toilet.
Okay.
All right. Yes, hello. This is Neutron Shield. one other guy, I think he's on the toilet right now, coming back any second. So Neutron Shield, yes, it's an interchain DeFi management tool. And well, let's get into why this is needed. So imagine you're a great trader. So you're out there in the DeFi world. Let's say you open a position on Injective. They have perpetual markets, and you go 5x on the Atom perp market. And all good so far. But of course, even the greatest trader, trading is stressful. So even the greatest trader at some point is going to need a vacation. And well, you go out on vacation out there in the world. Are you going to take your ledger? It's a bit risky, so maybe not. And also, like, you may not even have internet wherever you are in the world. And also, it's not a proper vacation if you're always stressed from trading, right? So, well, you come back from holiday and you see, oh, price went up, all great. Everything is good. And then you look at your position and you were fucking liquidated. And I was like, what happened? The price went up, you should have made some money. Well, how is that possible? It's the reverse part, right? The price went down, you got liquidated, price went back up, and yes, so you couldn't react in time because you were on holiday. So, well, this is where Neutron Shield comes in. It's basically allowing you to take some time off, and well, the way this works is basically we have a smart contract on Neutron, and this smart contract is able to connect to other chains in the interchain universe. And well, first you would deploy this contract on Neutron, and then you would register an interchain account on whatever network you want to manage. So in our case, it was like Injective. And then on that network, user would execute message grant with Auth3 and basically say, hey, this interchain account is allowed to execute certain transactions for me. So the funds actually never leave his own account. And then back on the Neutron side, you would register a user-specific interchain query. And Neutron has specific support for that that we used. And then lastly, you'd also register a user-specific cron job where like this is automatically executed, and in our case would regularly check, hey, is my position close to liquidation? And then if it is, it just tops it up with some more money. And now demo time, if we have enough time for that.
Hey. We're going to do a demo. Yarn dev. Hey, cool. So this is Neutron Shield front end. Welcome, everyone. As Marcus mentioned, Neutron Shield is a smart contract that's registered on the Neutron side, and it allows you to use interchain queries to, in our situation, like manage positions across the entire Cosmos ecosystem. But in our demo, we're really just connecting to a Injective account where you're going to be looking at a particular account's sub-account IDs and like market to see which open position they have, and then be able to perform actions on their behalf using the Neutron smart contract. So you would first want to connect your Injective wallet, as you just mentioned. Then you want to do grant permission. This gives you permission to the Neutron smart contract to then do OBZ to the Injective smart contract, so the Neutron smart contract can perform actions, as we mentioned. So you would say it's cool. Then you want to switch over to the Neutron side, so you would connect to the Neutron wallet. You want to select a market for your open, like to see which market you have an open position in on the Injective side. Then here you have like your margin ratio. So, oh, okay, I'll just wrap it up. Margin ratio, see how close you are to getting liquidated. If you're getting too liquidated, you're going to want to auto top up your position. That's going to use the interchain query to actually let the Neutron Shield smart contract to see how close your position is to liquidation while you're on holiday, and then auto top it up. Oh yeah, okay. In nature, everything is interconnected. It's a wonderful dance. And that's what we're trying to achieve with technology by Tim Berners-Lee, the creator of the World Wide Web.
All right, next up, Aura NFT, who built on Aura network. Come up to the stage, please. I think for the smooth process, it would be better. The next step, next team would be, around this area, like prepare to plug in their laptop. So next team will be CW Prologue. So please come around this area so that we can start soon.
Hi everyone, at Aura NFT, so we would like to reward loyal customers, track and reward loyal customers. So what our selling point is, we would like to provide increased security and transparency in tracking and rewarding loyal customers. The power of blockchain provides instant customers reward. It's also able to track and manage loyalty very efficiently, and points or tokens can be distributed across loyalty program. So the problem is, established plans still struggle to retain loyal customers, need easy to use tools and secure track and reward. Needs to maintain different loyalty program for engagement, and of course, needs to be secure, transparent, and efficient. So of course, blockchain-based loyalty program provides this kind of tracking customer purchase mechanism. Rewards with digital tokens can be stored on blockchain. Token can be redeemed for discounts, merchandise, and other experience. And also, blockchain provides instant rewards, removing third-party provider. So we built an Aura network. So our idea was to the first feature we wanted to build was providing NFTs to large amount of customers in a different category. So we wanted to see how we can do this with a smart contract. So we tried to play around with the execute receive function of the CW721 smart contract. But it didn't really support our purpose. So actually we just deployed a normal CosmWasm 721 NFT smart contract to Euphoria Aura network. And we use TS code gen to create TypeScript contract provider from a contract schema, and we used many tools from Cosmology and Cosmos Kit in the front end to build a very simple prototype. Actually, I cannot show you much because we had a lot of problems. So, so it was very difficult to get the all the details for connecting the Aurora Euphoria network to the wallet. So as you can see that the wallet is connected. And we are connected to the testnet of Aura, but as soon as we execute the mint function, we were not, so we had the problem in, I think it's the Cosmos Kit React, so it's the get client CosmWasm, get CosmWasm client function that was not working, so we were not able to connect the yeah, our network, our wallet to the network in order to mint the NFTs. So yeah, that was, but what we would like to, at the end, what we would like to really have is, different customers are categorized into different sections according to their purchase, and they should be able to get different kinds of NFTs according to what they purchased. And we would like to prevent spam by maybe setting up certain times that they can redeem their tokens or mint the NFTs. And yeah, we would like to create a new marketplace where they can easily sell their NFTs to other people. So they also make a monetary reward. So yeah, actually that's it. Yeah, thank you for your attention.
Thank you, our NFT team, who kept on time the presentation. Appreciate it. And the next team up, CW Prologue, please. And this team built on OKP4.
Hello. Okay. Shit. Okay, all right. Yeah, so hi, we are CW Prologue, and we built, actually, we took it more like a research challenge, and so we didn't think about the product, but we went through a couple design considerations for ways to implement logic programming with CosmWasm. So the background is, to give you a bit of background about the OKP4 chain. Is this okay? So it, you can kind of consider it like, you know, where Bitcoin and Ethereum are for settling on like transaction like amounts, like a decentralized ledger. You can think of OKP4 as like a decentralized settlement layer for facts and truths. So just a couple terms, and so I might have used a different definition of an ontology than what you can find on the OKP4 site, but I think an ontology is basically how your system represents knowledge and facts. So for each different project, how like the different types of nouns, how they are related to each other, the relationships, you can represent them and in code. And for the scope of this like presentation, we'll consider that as an ontology. And the basic idea is that we upload facts onto the blockchain, and then use Prologue as the language that lets you query against an ontology. So the OKP4 chain allows you to kind of upload a database of facts, and then, you know, depending on your use case, multiple participants in your network can derive truths about these facts and use those truths in their everyday like communication. And they have a couple of use cases, like, you know, whether or not to allow certain people to access a specific data set, or if you want to agree on a certain like facts based on what was published, for example, for carbon credits, like who contributed what, and how new carbon credits should be minted. And yeah, so what they've done is they have created a blockchain where people can kind of store facts on it and derive other knowledge from by running Prologue queries. Yeah, just to show you the power of Prologue, this is a full well, the first half is a full Sudoku solver in Prolog, where all you need to do is define the facts of the constraints of the solution, like all the length of all rows must be 9, and they must all be distinct, and then the various regions of the square must all be distinct, and Prolog will just generate the solutions for you by using its constraint solution solvers. So it can be very powerful as a data query language, which is what the OKP4 team has used to decide on Prolog as a data query language for their ontology protocol. Okay, so the problem that we chose to tackle is extending the Prolog interpreter with custom predicates. So imagine that you're trying to use OKP4 to create a knowledge system, and you want users of your protocol to kind of be able to query this knowledge base with custom predicates or semantically significant logic queries that you can't necessarily accomplish with base Prolog. So usually you can either ship some Prolog libraries, which are basically predicates written in Prolog. These are composed of basic fundamental blocks, but at a certain point you can't go beyond things that you can't derive because you need a new building block. So there's two ways. The current only way to do so is to literally upgrade the chain and change the code inside native Go. We have explored two ways of extending Prolog using CosmWasm, because we think that using CosmWasm allows you to dynamically upload here we're using CosmWasm as a plugin system where we write language extensions as Prolog modules. CosmWasm modules. Okay. The first experiment is we embed a Prolog interpreter inside a smart contract. So we basically added a crate called logru, which is a Prolog interpreter. It works, but it's weak, and the problems were that it was an incomplete version of Prolog, so we'd have to add more advanced things into the Prolog interpreter. So it's actually less powerful than OKP4's native Prolog engine. So we decided that our second solution would leverage the power of OKP4's native Prolog engine. All right, and this is how you do it in. This is how you use the module that we created. So here's the contract that we added logru to. So we actually load a Prolog program into it, and then we can query the contract using CW simulate. So as you can see, the ask query is where you can add your and we've chose to put all the solutions in one giant string. Okay, the second experiment is writing language extension contracts in CosmWasm. So actually, the CosmWasm contract itself would describe a manifest of new predicates to add, and we actually forked the mainnet code. Yeah, 1 minute. Okay, mainnet code to. So we made we hacked the OKP4 node to kind of allow for this extension via CosmWasm contract, and yeah, so this just required a change to the protobuf where we put where the CosmWasm extension contracts would be located, and then we modified the logic module to dynamically load and call predicates defined in CosmWasm. All right, cool.
Thank you. The next team will be Only Votes, who built on Aura Network. Please come up to the stage. And the next team will be Starship OKP4. Please be on time.
All right, hello. This was it's going to probably be pretty short, and as this was like, I didn't actually get it working, but the idea was, or hi, I'm Adair. The idea was to use Auth so that you could sell your voting rights, because there's a lot of lobbying that happens on Twitter right now in Cosmos. So why don't we make that lobbying like actually financially possible by allowing validators and individuals to sell their voting rights? And so what I did is I created a marketplace where you could list your voting rights. It would, and you would grant Auth permissions to vote on your behalf, and it would give this to an NFT. This NFT, when you sell it and transfer it, there's a vote function that votes on behalf of you. And of course, the authorizer can always revoke the permissions or cancel the vote. But when you sell your vote, you actually have to post collateral, and if the vote doesn't go as the way as the buyer voted, then it transfers the collateral back. So I guess I could show some of the code. And so essentially, there is an issuance. So like, I would issue my my vote, or issue my bribe, allowing someone to purchase it. I have a price, and I post some collateral, and then someone can bribe me and buy the vote. And then the actual voting contract, you can transfer, you can cast the vote, and then you can verify the outcome. And yeah. So some limitations I ran into are you can't query proposals on-chain in CosmWasm, at least not in TestTube. And the other limitation I ran into is that while trying to test this with TestTube, the proposals would actually be just finished. They would finish very quickly, and so, yeah. Anyway, Auth is really cool, and I think there's a lot of cool things that you could do with this. So for instance, you could play games. You could play poker and bet your voting rights for something. You could take these voting rights and pool them together with others. And this is actually really useful for DAOs, because the DAOs can sell their voting rights to one person, or not even sell it. They can just delegate their voting rights of the DAO to one person, so the entire DAO doesn't have to vote. So, yep, that's it. Only votes. Thanks.
Thank you. That was the best. All right. Next team will be Starship OKP4, who built on OKP4. And the next team will be Dynamic NFT.
To change some settings, or okay, perfect. Cool. Hi guys. For this demo, we try to integrate Starship with OKP to run a bunch of devnets, and also to run end-to-end test with simple config files. So I'll go over what that is. So the problem statement is realistic end-to-end testing is done very late in the development lifecycle, and so what ends up happening is you find bugs, or people spend a lot of time spinning up like real VMs or like multiple Docker containers, and then find like bugs closer to mainnet launch or in testnet, and we just want to make that faster and more easier and cheaper. And so yeah, spinning up multi-node validator setup in Interchain is still hard, and we want to simplify it. Cool. So what Starship provides you is like with a simple configuration file, you can spin up the whole interchain, and this we want to expand. So you can specify the chains you want, layers that you want to spin up between what chains, explorers, chain registry, and basically we create a whole mini Cosmos inside a Kubernetes cluster anywhere in local CI and DevNets. We have integrated CI/CD for it, and so it's been written with testing in mind so that we just don't want to have these DevNets of sorts. We can have regression tests there and then run them, have tests in like any language that we support, multiple languages. So you can have CosmJS tests, you can have Go or Rust. So we separate the infrastructure from testing, and then once the infrastructure is up, you can write tests against that infrastructure. Cool. I'll quickly go on, into the demo itself. So with OKP, which is a Cosmos SDK chain, we created a bunch of, we created the DevNet and created some test, IBC test. We also found a bug and fixed it on IBC because it didn't work properly with Hermes. We'll show it's just a small thing, but now it runs. So okay, let the demo gods be with me. Cool, so we have a Kubernetes cluster already running. Okay, I'm cheating basically. So this spins up in under a minute. What we specify and what we provide, I'll quickly go over that. Okay. Yes, so we have a simple config file. Again, this can be even shorter, in which you specify the chain you want to spin up. So we are spinning up an OKP chain. The type is custom. You can have default types of like 15 chains that we support, and then the whole thing becomes shorter. We spin up a Gaia chain with number of validators, 4 validators, and then we spin up 4 validators for this as well. And we can provide it resources and stuff. This is Helm chart and all Kubernetes and the backend. We spin up a Hermes relay between these two chains, and by default it creates an ICS20 channel. And we spin up our own local chain registry as well, and there's a ping pub explorer in the DevNet. And so what it ends up looking like is like you have CI YAML, which is the same YAML with less resources, and you can run this in the CI. DevNets with more resources, run it on a Kubernetes cluster, or you can run it locally as well. And then you can have end-to-end test on this. So we have like 2 tests basically here, which is token transfer and then IBC transfer between the 2 chains. Cool. So we also spin up a chain registry, and here this is the chain registry. We have the IBC part, which is the most important thing for writing tests, and this is all script, so you can get the connection channels, all those kind of things to write your own test. The chain registry is a single point of entry here. Cool. What it ends up looking like is like these are the nodes that we are running. We're running like, I said 3, but we are running, I said 4, but we are running 3 nodes for each of the chains. So Gaia chain is running here, OKP chain is running here. We are running a Hermes relay and a registry and an explorer. So what it ends up looking, we are running a ping pub explorer, so you can see that these are the 3 validators, and yeah, ping pub works, sort of. And sorry, let me quickly go over the end-to-end test. So what, yeah. So these are the end-to-end tests. In the CI, we found this bug, and yeah, we fixed it. So what it ends up looking like in the CI is it takes 7 minutes, but you spin up the infrastructure in the CI, and from the CI, you can also connect to a remote Kubernetes cluster, but currently we're just running it in the CI itself, so we're running with less resources. And then once the test, once the infrastructure is up, then you run the, yeah, the infrastructure takes some time to spin up. This is all Kubernetes and Hermes. Hermes, everything. Okay, that was a mistake to open this. But wait, yes, test is what I wanted to show. So yeah, we do Go mod as well. This was also bad. But here are the tests that are running, so you can make sure you can be sure that this is running again. Actual Hermes and actual like version chains and all this kind of thing. So the cool thing about this is you can also run it against the real versions of Hermes and stuff. And yeah, that's about it. Cool.
All right, next team is Dynamic NFT, who built on Aura Network.
Hi, everybody. I'm Stefano, and here my colleague is Alessandro. We are 2 developers from Kintsugi. And yeah, 1 second, that presentation is starting. Okay. Okay. So we are a particular team since we are 2 guys, but with only 1 computer since I broke mine before starting the HackWasm, so was very unhappy coding these days. But yeah, our starting idea is think about NFT. You have a collection of tokens that are every token is different from the other one. And we have also badges where we have a single collection that shares the same metadata for all NFTs. And thinking, for example, at conferences or hackathon like this one, it's very nice that every participant have only a badge for participation, but we can also think that we have, for example, winners of competition, and so a single badge is not enough to express this, this environment, and also every NFT different are still not enough. So we think to build something that is a kind of NFT or a badge, but with dynamic metadata. And this is the review of what we build in these days. It's the general workflow of the workflow that we create. And so we have a factory for instantiating the contract of the badge NFT. And all badges have the same admin. That is the factory. That is the only one that can instantiate and execute all the logic. We built the contract that is the dynamic NFT, leveraging the modularity of how CW7021 is built, and which is also the same that was leveraged by SG7021 and badges. So it's like a class that inherits from the parent, and so our dynamic NFT is nothing that a wrapper around all these contracts, but during the instantiation, we embedded inside the contract also the state for storing all different metadata. And yeah, we can talk about the workflow.
Yeah, I just want to have you a little and quick overview of how this works. So let's imagine we are here at HackWasm, and so the organizers could, for example, create a new badge NFT collection like HackWasm Berlin, so they have to instantiate a new contract like this. Then, for example, they mint the NFT, they mint the badges, so everyone get a badge, like a participant badge, because the default one is like participant. And then after the hackathon, and so after the judges can judge who are the winners, they can trigger this function, this turn metadata, which actually didn't put a new metadata, because metadata are already put in the instantiation of the contract. So it just points to a different metadata. So when you have to do the query on the NFT, on the badge, you have the returns you have is not the default one, if you're the winner, but yeah, the special NFT, the special metadata for the winner. So it's really cool. And yeah, what we have done, we have not a demo because we ran into some little problems, and for the time we have not time for fix it. So we designed the whole logic, the first iteration of the spec, and also yeah, the implementation of the NFT contract, the implementation of the factory that has to call the NFT contract, and of course all the basic tests to verify that it was correct. And so, yeah, thank you for the time.
Thank you. All right. Next up, Objectify team, please. And they built on OKP4. Objectify team is here. Ah, okay.
you want to skip me for now?
It's not. Yeah.
Okay. All right. Hi, everybody. I'm Derek. I'm a one-man team. I'm all the way from Philadelphia, Pennsylvania, in the States. So I worked on the OKP4 challenge. So I thought it was really interesting that they were looking for more UI for some of their tutorials. So so as stated before, the problem, basically the background is that the getting started docs for developers has example WASM contracts for people to get familiar with doing development. However, there isn't really much left for UI and UX. So I figured it'd be I figured it'd be good to make a fully functioning in DApp with RPC connectivity to a wallet and their testnet. So that's where Objectify comes into play, and that plays off of the name of their one of their smart contracts. It's called Objectarium, and that's basically like a store, kind of like S3 for storing objects. So I figured I'd remix that with a CW721 library that I found for basically making NFTs on CosmWasm. So I put that together, or mashed that together in the time I had. That's when I trying to make a quick architecture diagram, but with the way most apps work, they communicate with like a front-end client. In this case, CosmJS, where it'll do the remote procedure calls to that wallet, and it'll do the communication to the smart contracts and the testnet. So I made a pull request for this. It's probably not right the first time, but this is coming soon. So the live demo is this. Okay, so just running localhost. We have basically you put in information for NFT. With the NFT, there's set things that you have put in for it, and then you mint. Then from there, it would be able to be uploaded to the Objectarium store, and you'd be able to execute all of the functions of the smart contract. So store, forget, pin, unpin. So basically, add it or remove it to the store, add it to like a smaller collection, like a bucket or something like that. And if it were working properly right now, it would be showing all of the addresses associated with it. And yeah, and the pull request is out there, and I'm actively working on it. So yeah.
Thank you. Next up, CrossFund. Tim, please come up to the stage. Who built on Neutron? Okay, so this is the 9th team, and we have 24 teams, and it's about 1 hour past, so I think we're on time. Awesome.
Hi everyone, we are a team of CrossFound. We are a crowdfunding platform for founding a project. There is currently a problem that there is no one common platform when all the blockchains could invest in one specific public goods, and that all communities could go together and not only think about their individual needs, but about the project that would be good for all the blockchains. So this is why we propose the idea when we connect builders, communities with the projects, and there is possible way to invest in this project from different kind of blockchains, and just pick up the theme and idea. The community is the most interesting for the specific community.
All right, so we got the higher overview, and let's go to individual components right now. So first component is ability to submit a proposal, and it's completely permissionless. Anyone can create a proposal, and it's going to be listed on the front end or possibly somewhere else, who knows. And another feature of the platform is ability to fund a specific proposal with any currency, with any IBC currency at the moment. So, I mean, you have a different ecosystem who might be interested in the same good, and the platform will keep the record of all the funds coming from across all the IBC ecosystem and show you what's the current USD balance for a specific bounty or proposal. And the way it works behind the scenes is we're using two IBC protocols. First of them is interchain accounts. The way it works is the logic resides on Neutron blockchain, but then whenever someone wants to fund a specific proposal, they can generate an account. They can request to generate an address for the specific ecosystem. So, if you're a whale on Cosmos Hub, you can just and you are interested in a specific proposal, you can ask the contract to generate an address for you, and then send your atom there without need to swap your tokens anywhere. And it should also be a nice way to use community spending proposals. So you just request an address, and then you send your money from community proposal there, and then the contract will take care of it behind the scenes. And this is the way it will take care of it behind the scenes. So this is another IBC protocol that we're using. So whenever someone sends funds to an address that represent your proposal on another chain, the blockchain and the contract will query all the funds incoming to the specific address all the time, and it will be registering them and keep record of who sent the money when, so that in the future they can control them and withdraw them from the escrow. And when it comes to individual development teams, anyone can propose their setup, their team to work on an individual issue or individual proposal, and we also require that whenever a team applies to work on a specific project, they also need to specify a set of auditors, and it's up to community to decide whether it's a legit setup, legit application or not. And another part of the equation here is that you not only can fund a specific proposal, but it can also decide which team, which application your money goes to. If you're not satisfied with any of those, you can just take your money back, and yeah, that's it.
Yeah, and we are a team of two. Martin is a Web3 engineer. I am UI UX designer, responsible also for a front end. And yeah, thank you very much for listening.
All right, next team, please come to the stage. Sweet. who built on OKP4.
Just wait for him to get connected up. But maybe to save time, I'll start. So, BitConnect. Just joking. So we're what? So we probably one of the less technical teams. We had a bit of unfortunate people joining. So it turned out the blockchain engineer was me, who started learning Rust a couple of months ago, and Cosmos this week, or last week. So I'm pretty proud that the contract just compiled at the end, to be honest. So we're Sweet, S-W-E-E-T, a smart wallet for everyone. It actually stands for Smart Wallet Engine for Everybody Technology. And the idea here is I'm very passionate about actual people getting onboarded. I know that we're all the nerds. I'm just like you. But most people, my sister, my mother, still have notepads on their computers about the password. Web3 is not ready for them. So how can we take advantage? The problem is access. The problem is inclusion, and the problem is control. You know these kinds of problems, like couples, they want to stay together and have a joint account, and things can change down the lane. Or a parent might to introduce their child to new technologies, but wants to control how they're used. So this is a problem we saw that can be solved with blockchain technologies. We wanted to make a solution that was user-friendly, versatile, and smart. So taking advantage of blockchain technologies to handle and obfuscate all these things. People are used to using their thumbs, taking photos of their faces. They're not used to MetaMask, and I don't know how much Ethereum is charging you for fees these days. So that's the idea here. We've got a repo up there. It's not fully working, we'll be honest, because of the technical thing, but we have got basically two aspects. There's an off-chain element, which my colleague Victor managed to get working, which handles cryptography on the off-chain part, which integrates with fingerprints and the usual ways people integrate. And then I started the idea of this smart contract, which basically is the vault. So the key features is that it's user-friendly and accessible. Anybody can use it. And maybe we'll show you the key application, which demonstrates what the engine's capable of. So do you want to talk through this?
Yeah, let me take that. Thank you, Z. So yeah, here's our application. For now, a prototype. So here you can see we first of all choose what kind of target user we are targeting. For example, here we choose a family, and we add all the parents, and then I add a child. And going on, I choose what kind of limitations or controls I want to add. And for example, here I'm adding a monthly limit of 2,000 euros for my child, Victor. That's pretty much a lot. And yeah, as you can see, after this is added, you can then share this with your child, who can then use this app to kind of sign in and get on. And then, for example, here we have this gamification feature. We award, if you're a nice boy, a monthly new NFTs that you can then show off to your siblings and to your other friends back at school. So yeah, from here I think you can take.
Yeah. So the key thing to notice here is that it's all about the use case, and in fact there's a smart contract going on in the end, but there's just one deployed to the blockchain, and people basically have keys to a vault essentially. So multiple keys, one vault, everybody's sharing. So you can think of it like a DAO, but without the voting. And apart from people in this room, most people don't want to vote more. Sorry, that's the real truth. Oops, that's the real stairs as well. So key features: decentralized and secure, smart contracts in real-time tracking and notifications, and you can also include a gamified experience if you want. So that's the main things: enhanced security, increased control, faster adoption. There's an off-chain part, as we said, which handles most of the cryptography, and an on-chain part is one smart contract, which is basically a vault, and then is activated to have all these different rules, which you can also opt out of. So you can basically say, that's our prenuptial, those are the rules. If we don't get on anymore, we still have to obey it. So more than just a wallet is the vision, more integrations, but generally helping people to have more control so they can forget about the technology and get on with their lives. So one for the rest of our families who are not necessarily coming to these events as much as we love them. So thanks for listening. I was on product and smart contracts, it turns out. And Anastasia was on design, Victor on technology, and Zaif doing the business development. So thanks very much.
All right, next team. So team's name is long. Okay, Mesa fork mainnet test in God mode or GOD mode? God mode. GOD mode. Okay, this team built on Neutron.
Uh-oh. Pit connect. Okay. Nice. All right. So my name is Jesse from Numetric. I just hacked away this thing called Mesa for the past 48 hours, and it's one of the things I actually pre-sold on CosmWasm, but I never really got to actually build it. I decided to take this moment and actually get to make it, and I did it. So. Fancy words, but basically it's like a test toolkit where you fork mainnet, and you have a fork network that's running just for you, and then you can just send transactions to that network, and then just forget about testnet in general. Because let's be honest, we hate testnet because RPC is always down, and there's somebody running it, and then there's no equal distribution of voting powers, and that validator goes down, and the chain is basically stopped. Or you want to test against some already existing liquidity, but then liquidity is always skewed or not really there, barely there. Nobody's really running any liquidation bot, so it's kind of a deserted place. But so I thought maybe, hey, the better way is to fork mainnet and you just test your contracts against it. This works for not just for the first time uploading contract, but also could be extremely useful when you're upgrading your contract. So what would you do if you could fork mainnet at any height? One click just takes 5 seconds, and be anyone. I'll talk about it later. So just a bit of demo. Here, so I have I have a running Neutron mainnet sort of syncing in background. I think the tip is the site. I think it's last night or something. I've stopped running it, and I'll fork at this site. Okay, I already have a database, so I'll just fork this site. There you go. So this I just picked 2 random wallets. To demo this, balances, you're showing balances, okay? You can see the heights are exactly the same, and then you can just go this, and then, so this Mesa test is a simple script that sends a transaction that sends 1 million microneutron from the wallet on the left side to the right side. So if you run it, something happened, and then if you refresh it, block went up, and then the balance goes up. This should go down. I'll probably the other way, maybe. But you can just run it many times. As you can see, it doesn't take time to it doesn't actually wait for the timeout. So that's a good thing because you don't have to wait for a block timeouts from validators. You can just forge whatever block, and then include whatever transactions in the block, and then just skip the blocks as fast as you can. So I've skipped 10 blocks now. So let's try it. All right. So. Amount is gone, and then this should go up, and then the height is bumped, so it's it has processed 10 blocks. And then you could also it's extremely easy to tear down. Is it okay? So I'll just rerun it for other block, for example. It'll go back to that height with the amount back to normal. As of the previous state, and then you can just spam your forknet again, and then do that, right? So it's mainnet's going on, mainnet's running its own pace, and then we have a fork testnet without having to copy anything. Okay, I'm now testing with the CLI things, but obviously when we launch it, it's going to be a one-click thing, or you can also call APIs pragmatically. So yeah, if you have a test code written in whatever language, you can just call simple post thing. It's something like that, Mesa next. You can also see block interval. I set it to be exactly 6 seconds, but you can make it 10 days for a block. This is kind of useful if you're protocol is like a time dependent, right? Because you can just change it and then, and as you can see, like for the demo, I'm just sending from address 1 to 2 with like 100 million microneutron. Notice that I'm not using any of the like set signatures. I'm not creating any signatures because these two wallets, I don't really have the mnemonics or keys for them, right? This means you can like impersonate any wallet that sort of exists on the original mainnet. That could be like IBC relay or coming in, like sending something to your chain or whatever whale dumping. I don't know how many like USDC onto your protocol. You can be anything. Hence, God mode. So how we made it? So Numetric as a company is basically high performance RPC company. So really have a running archival node for Neutron. And then we also have like a partially loaded TMDB. So this is the thing I kind of spent most of the time in the past, 48 hours. So partial loaded TMDB is like TMDB is a Tendermint DB thing that Cosmos uses. It only picks only the necessary parts of the mainnet, so that's why it's sort of lean. It doesn't have to copy the entire DB. It just copies whatever is necessary to run the simulation. And on crypto, basically, okay. So validator, no signatures involved. So same Cosmos code. So you can run this. You can treat it as like the same as Neutron. Signature bypass, be that whale or anyone. Time skip. Like I said, like you can just skip blocks really fast. So this, I think, will be really useful. Thank you.
Okay, so next team up, auth access contracts, who built on Neutron.
Start at the beginning. Okay. This is an idea that I've been kind of having for a while, and then we just really had a great time this trip, really coagulating ideas about auth. So I'm auth Purvis, and I'm going to talk about this really neat thing that I think is going to be, it's not monumental, but maybe half monumental. So auth, like ELI5, because not everyone's developers, and that's fine. So auth is you can grant an address, either an external one or a contract, the ability to be you, right? It can execute something and the blockchain thinks it is you, right? So an example on the right here is before I left for this trip, I set up my ledger that's at home so that I could run this script and compound my atom. And that's kind of cool because if someone found the seed phrase, they can't really screw me over. So it's a first idea of a seed phrase isn't super scary to lose. And so I'm kind of playing with the idea of calling this it's like a sidekick, right? Because you create this thing and it is you. And the cool thing about this, I work on Croncat as well. So if you have a contract on a blockchain and something inside the blockchain can call it, then you can basically automate as if you were doing something. So say you have a bunch of liquidity on some DEX and you don't want to withdraw it or something, you can actually create a contract that can act like you. And so right here, I'm creating Neutron keys, and I add this fake account, and that one is just brand new, and I can give that permission to do limited things on my behalf. So let's get some ideas. Your phone maybe has a different key. Browser local storage, which I'll show on the next slide. This is similar to how Near Protocol does it. It's kind of cool because then you don't even have to have a Kepler pop up every single time, and then it's your turn to brainstorm on what else can happen. So browser local what? So basically, and if you open up your terminal kind of deal, websites store this stuff, and so you can actually store a mnemonic there, a seed phrase basically, and then someone could click claim, and you give the ability of that seed phrase to act like you, right? So then you could go to a DEX and click claim, and Kepler doesn't even pop up because the browser is just signing with that key, broadcasting it, and there's no sort of need to pop up. So that's kind of cool. Easy mode, and this is kind of what I'll focus on here, is the access contract. So what does this look like when you're using the terminal to grant auth permissions? A lot of times you will say I I want to do like a generic authorization, and I'm going to say that like this key is able to do this one message like on my behalf, which is really cool. So this is an example of like this can execute a smart contract for you. But then generic gets even crazier, and I think the injective guys mentioned message grant too. So you can, and I know I'm like going to hurry up here, but let's like slow down for 1 second because this is kind of important. So you can like grant an address the ability to grant auth privileges for you. So it's kind of like this like inception idea. That's pretty wild. So I figured out that was possible, and what can you do with that? I think account abstraction is like really going to come in handy here. So let's kind of stretch our brains. What happens if you make a contract that's allowed to like pretend like it's you and grant other contracts the ability to be you, basically? Quick primer on Instantiate 2 from Simon. I would really recommend reading this, and this goes over like some of the limitations, but when I read this, I was like blown away, and I did not see it as a problem. I saw it as like a strength. So my project that I started, this is like the vision. I will say that like for this, like this is the main one that is working right now. So basically we have like, forget the first one. The first one is basically like all the problems that Simon mentioned in the blog. I fixed that by like having Instantiate 2 in a contract, so you kind of like control a few parameters. And then the idea is that like every person can create their own sort of access contract extruder. So an extruder is like Play-Doh when you like put it in a little like thing and it comes out as a star or whatever. But extruders are kind of like for metal usually, something like hard for building. So you can actually create your contract extruder that acts just like you, and then you say, hey, create me a key, like a contract that is able to call wind dex at these two functions, and it will basically like bake that data into the Instantiate 2, so like the contract address that is made from that has like a relation to the power that is granted, essentially. I won't camp on that too long. I will say that this is something that was pretty cool. Hardcore shout out to Mark from YieldMost, who's been really like helping me out here. So basically like authz has some like protobuf stuff, but you might want to make it even more granular. So this is an example of how you can basically use a smart contract to like whittle down the Cosmos message and be like, okay, you are someone that I trust. Yes, you're trying to call a function that you're allowed to, and maybe the funds are below this certain amount. I will therefore authz execute, and like that means like act just like you. So that's pretty cool. Basically, we can do anything with authz with this way. I'll go a little bit faster. Oh yeah, so I did this for Neutron. Psych, they do not have these things in the Neutron mainnet right now, so I actually can't do 2 of those because Instantiate 2 isn't on Neutron mainnet, so maybe I'm not in the Neutron track, but whatever. And then the next part, this is Mochi, by the way, my dog. The next part, like what's next? Okay, so this is a wild idea, but like really what we should be moving toward is stuff that Larry is talking about, where like, basically you don't even have EOAs, you just have keys, right? Keys that are like talking to contract accounts or contract wallets. And those keys, just like my Ledger one, getting close, okay, cool. Just like my Ledger one, it's not catastrophic, which is why Mochi is like very like happy and calm, because you can actually have a bunch of different accounts that represent you that don't have super scary seed phrases. This is Larry let me share this. Basically, I'll kind of skip over this until I'm over time, but if we use Larry's account abstraction SDK module, then we can essentially achieve like function call access keys on near in Cosmos. And I'll go to the last slide actually here. So big thank yous. This has been like honestly like a group effort. Sam Hart I think is here, and he like led the idea of authz, which is massive. Confio did this thing in November that is extremely important. Contract execution authorization. If you haven't heard about that, then check that out. Bart is here. He created something that saved my ass. And then Robin Adair, Ethan, YieldMost Mark, Belsi, Boss doing some stuff with Osmosis STD really saved us all. We all kind of like had this like authz like revelation together at a campfire, so I want to give thanks to all those folks, and so does Mochi. Cool, thank you.
Next, Connie and Brown, who built on Finchia. Please come up to the stage. So while Connie and Brown team is preparing, just a little information for you guys. Just a big shout out to Stargaze team who built amazing HackWasm Berlin POAP for us. So if you didn't, you were too busy hacking, you didn't have time to claim your badge, please do it. It's available until next week. And you know, this is our first HackWasm organized by Confio team, so you don't want to lose the opportunity to have that.
Hi guys. I'm Gemma from Team Coney and Brown. We built a smart contract using dynamic link and IBC structure through the Finja track and HackWasm. So here's the background. Firstly, I'd like to give you a brief overview of why we chose to develop this product. With Finja, users can stake their tokens through which is the line blockchain scan to various validators, which offers the various commission and various ALR. Once the validators are filled to capacity, there is a possibility that project may need to manage the pool of the size. So therefore, if a user is late to the process, the validator pool that offers the highest rewards could be full, so preventing the user to stake. So there we started. So here's the structure. So the smile face in the middle is smart contract. Once the user stake to the smart contract, once the user stake their token, the user can get an NFT as a reward. So this reward NFT is transferable. So if a user wants to sell the NFT, or the user B wants to get a reward instead of user A, they can transfer each other the NFT, so the user who has the NFT can get a reward. The contract also has a swap feature, so if there's like different chains over there, like Coney and Brown is different chain. So if the user has a Coney token, the user can swap into the Brown token to get a Brown reward. Or if the user has a Brown token, the user can swap into the Coney token to get a Coney reward. So as you can see here, Coney and Brown are separate chain. The smart contract automatically stake the token they get to the validator, which is the lowest commission. So if the user stakes the Coney token to the contract automatically stakes to the Coney chain, which is the lowest commission validator. At the same thing happens in the Brown chain too. We also use the dynamic link, which has the kind of convenient feature to make a smart contract. So in the caller, we made a function of staking, reward, swap, and transfer. Also, we made a function in Kali, had mint, transfer NFT, and burn. There's a demo and demo videos in our page, so you can check out like this, like store contract, initiating contract, or reserve coin to the contract, and so on. So if you are interested, you can check the videos over the demo videos. Yeah, this is it.
All right, next team, Sushi Roll. And Sushi Roll built on Aura Network.
Hi. Action.
Okay. Okay. Our project is Sushiro because we are from Japan. And in short, smart account from user onboarding to its management. Okay. Okay. Our concept is simple. Problems cost to use web services such as transaction fee, and it has many tasks. Create exchange account and KYC and login trade, withdraw, send to wallet, and then use. And it costs gas fee or some. User account management. Users easily lose their asset or leak keys by hackers attack. We want to solve these problems. Gasless onboarding for user. User don't have to pay any fee. It's free. Free source everything, and flexible access control for user. User can recover their asset, and service provider can limit access. Maybe whitelist addresses and methods to safe use, to protect from malicious contract, unlimited approach, such as. And can we all network do this? There is a question, and of course it, or a network can. I want to explain how it works. First, we will use gasless transaction with fee-grant modules. It implemented as a Cosmos module, and it covers other transaction fees like approval method in ERC20. The relationship is like a grantor to approver and grantee to spender. Grantor admit grantee to spend like 100 hours, and we will use smart account. It is implementing flexible access control like account abstraction in Ethereum. Users can easily use it as a contract wallet. Next, I show the architecture. Maybe. Okay, can you see? Okay, in our application in testnet deployed, user first user service provider like application how can I say game file or NFT market or something deploys the contract to it implement business logic or asset or something. Then service provider want user to use this contract or service application. Then user application for use to their UI, some website to and enter the address to service provider. Then service provider allow fee grant to user's wallet. The user can send transaction without gas fee. The user activate request or smart account wallet with gasless. And next, service provider allow fee grant to smart account itself. So smart account can execute any transaction. The user next user want to use this contract and NFT, for example, NFT request to a smart account. Smart account execute the mint function to the contract with gasless. Here is the architecture and in detail user onboarding flow. Maybe difficult to understand, but important thing is user have to submit address and notify and service returns smart account address. Then user should do is just activate smart account with no gas fee. So 2 steps, only 2 steps. It's really easy, I think. I will show you the demo or part of it with meetings CW71 token from account with no gas fee. We don't mean it. Okay, I prepared, so just send mint command. I prepared a script and contract address and token ID and grant address. Okay. Okay, and then let's check it. Testnet. And the important point is contract and sender is both of them is contract and sender is the smart account. And open it, check the transaction is exactly executed, but the contract have no tokens, but have for NFTs. It's test for test use. Yes, it's a short term, but that's all. It is same same ink activation. Then next, okay. Anyway, we saw in this with this architecture we can use we can solve user onboarding and user account management and user access control programs, I think. Okay, and feature works, auto recharge, gas fee. Okay, service provider have to grant fee. The only work is service users grant fee. So I want to automate it, and the second, a more easy onboarding. So many other way to log in for user convenience. Thank you for listening.
Alright, the next team is the Alpha Beetle, who built on OKP4. The Alpha Beetle.
Okay, I think I changed that, but yeah.
So, hi everyone. Let me plug in HDMI into this thing. Might as well start like this. Do we have a picture? No. Oh my. Yeah. Perfect. Thank you for the patience. So I may as well begin. I'm going to get this script out. So I represent Hack.big. We're an engineering agency on the intersection between the free software, cypherpunk, and DeFi movements. Sure, we build DEXs, oracles, NFT drops, you know all that. But we're also constantly on the lookout for opportunities to push the envelope further. Not just make the medium of exchange do clever tricks, but to reach directly into the source of value. OKP4 immediately stands out as one such potentially transformative technology. So 2 months ago, we published version 1.0 of our DAF groundwork. let's not call it framework, let's call it the groundwork. It's called Fadroma. Last week we came here to Berlin to scope out which new chains to support and found out about OKP4. This is the exact kind of feature set that we have been hoping for, a classical but underappreciated architectural paradigm ported to a contemporary decentralized runtime. Adding this into our cross-chain toolset will be a no-brainer. However, I believe a major reason why this family of technology is not yet living up to its full potential remains overlooked. User interfaces remain trapped in thinly veiled scaled morphism. A text editor is just a flat typewriter. An audio workstation is just an infinite tape recorder, a web browser is an endless newspaper. Okay, they're all boxes. And those boxes, from finance to fine arts, all sorts of abstract concepts, all flash before our eyes as flat boxes. Even at 4K, these boxes fail to represent the dynamics of complex systems for those who need to see the world at a greater level of detail. There is, however, one kind of program which leverages human perception to the maximum, the video game. There, the interface does not hide the complexity of the system, but makes it accessible and tractable, truthfully and transparently. On the other hand, personal and business apps, including DeFi, evolve in the opposite direction, until they begin to cash in on the learned helplessness of the user. But the real world is not linear. The real world is hyper-connected and humans flourish among its complexity. Thus, our internal R&D program has consistently pursued the goal of creating fluent UIs that embrace complexity to enhance user productivity in non-linear work, individually as well as in teams. OKP4, being a novel, generic and composable system for describing and reasoning about complex systems, ontologies and dynamic conceptual structures, is an ideal fit for our Fadroma-powered graph-based interface. With it, we plan to make the power of OKP4 accessible not just to those who achieve mastery of the dark arts of Rust and Prolog, but to anyone who has ever played a real-time strategy game. During the present hackathon, working on top of a prior proof of concept and on 3 days of no sleep, I made the first steps to connect OKP4 with a portable graph-based interface, which runs in a regular garden variety browser, using Fadroma as a thin layer of glue between the two systems. I will now present some screenshots of the capabilities of our visualization framework as applied to the context of Cosmos blockchains and a brief technical demo. So where should we start from? So yeah, these are a bunch of screenshots of the thing that we have been researching recently. This represents the uploaded contracts on secret network. I think this one is for the mainnet. The red ones are duplicates. They have the same code hashes as other ones. This means that the gas spent on uploading these contracts as well as the storage has been wasted. This is the type of direct, easy call to action that may be identified using this type of analysis. This picture tells me that the current generation of dev tools that people use to upload smart contracts are not convenient enough, not fluent enough, and people make mistakes with them with the same frequency as there is already in this picture. This is another quite interesting thing, which is mostly a result of a performance demo, which you will see in a bit. Here you can see that the force-directed graph algorithm that we are using, this stuff all runs in real time, is automatically separating the wet from the chaff, like the duplicate contracts are moving in one direction while the other ones are getting in the other. This is the type of interface that I envision as close to a strategy game, like I said. It can start as something as simple as like this, just showing the status of every blockchain supported by Fadroma. Currently, version 1 supports only secret network, and OKP4 is now on the top of our list. We could get something like this. As far as I remember, this is an illustration of how many people reuse addresses between mainnet and testnet, even though it is inadvisable from a security perspective. These ones are the reused. This is the same as the first picture, but with a different level of highlighting, and this is what I'm particularly proud of, as it can be the start for a nice interactive infographic. So you can represent a slice of a complex system to a targeted audience interactively. It started with simple things like this, like does anybody have a map of which tokens are supported on which dexes? I've seen like the graph-based map of IBC and which chain connects to which in terms of IBC, but nothing on the contract level. And the beautiful thing about this approach is that we can scale it down not only to the contract level, but to the method level, to the data level, all things that we will explore with the OKP integration. For now, just let me show you that it works on a reasonably recent Intel GPU. This is the nice thing that I started doing like performance optimization on it, so I broke it. So I will just show you the all one. First, you can fetch data. In this case, it queries the code IDs endpoint. Don't remember how it's called, but basically all code IDs who uploaded them and the code hashes. This I'll show you next. Let's fetch from secret for mainnet and display everything. And we have about 2,000 like independent entities working at 60 FPS with just an Intel GPU. Now one thing is it doesn't know where exactly to stop with this layout. But if we pump it a little bit so it keeps moving, eventually these little shapes form. And on this we can focus. These are basically artifacts of individual deployment processes of individual smart contracts projects on the mainnet. Currently I'm not showing which projects they are. I just want to give an example of how each one, like I like to say, tells a story. It identifies there's like one developer who is having more problems with his tools and one which is having less problems, but that's because he's also trying less. For example, that's one hypothetical explanation. This is just code uploads. If you connect them to contract instantiations, contract instances and transactions, this is a way to get actionable insights about many aspects of the real present-day state of the Cosmos ecosystem. If we add the data from Pulsar 2, this is why I showed you the prettier front end but broken. It is going to be a bit slower. Okay. Okay, real quick. Once this whole mess is settled down, it continues at 60 FPS. As far as the integration of OKP4 goes, which is going to be my final remark, this is everything that I have been able to scrape from OKP testnet. So this little snowflake picture, it can be the beginning of a beautiful crystal and a very complex system. I advise you to get in on the ground floor with this thing because I personally believe it's gonna be huge. Thank you for your attention.
All right, next team is Bad Bridge, who built on Neutron. Please come to the stage.
Hi, everybody. We are the last two standing from Bad IBC, building the Bad Bridge. So I'm going to start with a couple slides, and hopefully we can perform a demo. There we go. So, Bad Bridge. It is a very bad cosmic bad kid abduction system, and it's been built on Neutron. Oh, we don't have it. There we are. Bad Bridge, as I said, a very bad cosmic bad kid abduction system built on Neutron. So we want to talk for a minute about celebrating baddies who are free. Being free is being bad. We got some pterodactyls, we have some other people on motorcycles, but really we want to tell you that bad kids want to travel the cosmos, and we don't have any time to wait for it. So you need ICS 721 to be deployed on all the different chains that support NFTs for them to be able to travel over IBC, unless you use this hack, the Bad Bridge. So the Bad Bridge uses interchain accounts and interchain queries in order to get bad kids off of Stargaze without ICS 27. Now the way that works is on Neutron, we create a contract. That contract will create an interchain account on Stargaze. That interchain account acts as the escrow for these bad kids to be moved across. So once that account exists, you take your bad kids and you send it to the interchain account address on Stargaze. Now,
Back on Neutron, we use interchain queries to confirm, did you actually deposit your bad kit into this escrow account? If so, the smart contract on Neutron will mint you a bad kit voucher, and you've just bridged your bad kit through the bad bridge. So, other places you'll go, you can go on to Osmosis Dex, Omi Lending. We don't really know. All we know is that we got your bad kit out of there and it's in another dimension. So as I said, the Neutron Interchain TXs, it's basically contract-to-contract calls, but across blockchains. The Neutron contract owns that account on Stargaze. The Neutron contract is configured to only ever execute an NFT transfer. That way it's not going to do anything else with those bad kids while they're in the ESCO account. There's a background prep to create the account, and there's an ongoing requirement to run 2 different relayers. That is what is happening right now. We have one for the interchain account messages and one for the interchain queries. Interchain queries. So the Neutron chain needs to know what bad kit has been deposited. To do this, they look at the state from Stargaze. That state is carried over. You pay 1 neutron to deposit to run this, and you get 1 neutron back when you're done running those queries. Parsing this information is not easy, so shout out to Maritz for finding a hacky way to do it that kind of works. Also, shout out to Kayansky, Nick, who's not here. If you can see in this screenshot, it is timestamps from the Stargaze Discord server, starting from 4 p.m. yesterday, going about every hour until 6 a.m. this morning. We went to bed kind of thinking that we weren't going to be able to make this work, and we woke up and he pulled an all-nighter, and our very last stretch goal was achieved. So the front end, using Create Cosmos app, Cosmology, huge help. Shout out to Dan Lynch. We started with the NFT transfer template and used the bad kit client. Apologies for the ugly code. Don't use our repo as an example for the front end. Please look at all the new Cosmology stuff. It is very clean. Shout out to Dojemos for our bad design. And shout out to bad kit creator Cortland for our bad bitch drawing. And hopefully now I can do the demo. Oops. So, can you all see that? Here we have our bad bridge. Don't tell us what we can and can't do. You begin by clicking be bad. Since we're being bad, let's switch to dark mode. First thing we're going to do is connect our wallet. Here I am, bringing it in. I'm Bad Billy. Here's I am with Stargaze and all of my bad kids. So this is my Twitter profile. That's the one I'm going to risk for this demo today. Find freedom. Transfer bad kid to another dimension. Here's our pop-up. So this is a Stargaze smart contract. I'm actually sending my bad kid ID 84 to the Stargaze address. Demo guys, be with me. We have a transaction successful. Great. So now find freedom 2. This is where we let the new dimension know that we just did this. So this is where we start the interchain query. Uh-oh. Wallet is undefined. I got to reconnect. We are going to let the Neutron chain know that we deposited. It's going to kick off the interchain query. So I put in a deposit of 1 neutron so that nobody's spamming these interchain queries. Wait for a second for that to succeed. Oh. This one usually takes a second longer. All right. Now if I click it really quick, I'm going to get an error. And that error says that it doesn't know about it yet. That transaction was just to begin it. So now we have to wait for a second for the querier to grab that information from Stargaze, bring it over, and deposit it in the smart contract. So hopefully the next time I click this, it'll be over there. And freedom will finally be achieved. So here we are. This is me minting my bad kid on the Neutron side. Da-na-na-na-na-na. Da-na-na-na-na-na. Yes. All right. So let's check it out on the Block Explorer. We can look in here is my account with my assets. Here's my Neutron. View 1 unsupported asset. Look at that. Factory token, bad kid, number 84. That is correct. Okay, so now in this view of my bad kids, I can refresh and see my bad kid is gone. But if we want to be good and we want to bring our bad kid back home, we got to be good. Here he is on the Neutron side. I'm just going to click him once. This is going to burn him and send him home. When we get our approval, we can refresh and see he's gone here. Go back to be bad. Refresh. Refresh. Oh my God, where is he? And there he is, right there. Round trip on our bad break. So if you thought that was good, what would you do if I told you that was all on mainnet? It wasn't on mainnet. I just want to know what you would do if I told you that. So on testnet, it is possible to do this today. Interchain accounts and interchain queries are live, they're running. There's only one problem. Currently, the way Stargaze is configured is you can't send the bad kid back until a proposal is passed to allow you to execute interchain account messages. So look for that discussion on Commonwealth. That proposal will go up in the very near future. And if you want to see bad kids going out, but also being able to come back in, vote it through. Thanks very much. Sorry, last thing, bunch of questions about what's next, but most importantly, I just wanted to say thank you to the team and Pi, everybody.
Okay, now next team is code verification API for Neutron, who built on Neutron team. Neutron network. So while we are waiting, a little information. So there will be a special presentation, which is not a part of these 4 Platinum sponsors track. It's about mesh security, whose prototype was revealed last HackWasm in Medellin. And there was the mesh security team would like to show their working in progress, and what they have achieved during this HackWasm time. So it will be done. This special presentation will be done right before the winner announcement.
Hi everyone, I'm Suya. Today I'll be presenting on code verification for Neutron. We often say that the code of blockchain is transparently open to everyone, but more accurately, it's not transparently open, but anyone can verify it. So, what is code verification? It's comparing whether the compiled source code matches the on-chain bytecode. Smart contract deal with asset, so it's very important and necessary to make sure the contract code on the blockchain is working the way it's supposed to. In Ethereum, due to past hacking incident, almost the contract codes are usually verified for safety. How about the case of CosmWasm? In CosmWasm, contracts are written in Rust. However, compiling Rust into WASM is not deterministic. For example, even with the same code, if you build it on a different OS, a different binary is created. This is why verification is currently challenging in CosmWasm. For accurate verification, the best method is to preciously know the build environment. We are already operating Remix ID for Neutron with a compilation server. So our idea is that for contract compiled and deployed through Remix, we can store the compiled environment and files and code ID, checksum, and verify them when a verification request is made. Let's look at the demo video. Let's deploy and verify the IBC transfer contract, one of the Neutron SDK. When the Neutron IBC transfer contract is compiled and store code is done through Remix plugin, you can get a code ID, and when you instantiate it, a contract account is created. In this process, we can store information about the source code and deployment environment in the database. And then you can access the verification service to verify the contract. Since the Remix plugin supports Juno, so Juno can also be supported in the same way. The code ID and checksum stored in database when deployed through Remix matches the current on-chain code ID and checksum. So the verification is completed and you can review the source code. But what if it is migrated in an environment other than Linux? In this situation, we cannot verify because the code ID is different and we don't know where the code was compiled. The key point of this service is that verification is done through the checksum, and we clearly specify the environment in which that checksum was created. As Neutron prides itself as the most secure permissionless smart contract platform for interchain DeFi, the verification process becomes even more crucial to maintain its security. Yeah, for verification again, if the migration is done again through Remix, verification becomes possible. Yeah, yes. Due to the limited time, we have carried out a proof of concept during hackathon period, but we plan to implement more things. Yeah, through this service, we provide value to DeFi projects operating on various chains, and we can prevent DeFi accident in advance, and the culture of verification will enhance trust in the Neutron. As we provide the entire build environment, you can verify it yourself, and giving up on self-verification would be giving up on one of the key elements of Web3. Remember, don't trust, verify. Thank you.
Is it not working or what? Takes a sec. Okay. So, mesh security. Yeah. Okay, perfect. So, there's the slide. So, what is the mesh? So, over the past, like, obviously since Medellin, the mesh has been like a thing. And the mesh in itself is just an alliance of chains, right? It's a bunch of chains that are able to share security through staking to one another. And usually those shares of governance allow one chain to have influence over another. And the mesh allows all chains to have influence over all other chains and provide them security through the security of their own native token. And it goes further than just how the mesh works, right? The mesh itself is also, I would say, more like an ideology within Cosmos. So when I say ideology, I don't mean like psychologically, right? It's one of multiple camps. It's, you may want your chain to be secured by one bigger chain that essentially is the overlord to the smaller consumer chain. Mesh allows these interactions, but not only one way, both ways, and with parameters that can be very clearly set to say that this chain will have 30% influence over my chain, but I will only have 10% influence over this larger chain, right? So let me give you a look into how we built it, at least the front end side of things, and how the UX of the mesh is going to convey much more than just cross-staking. So let me give the mic to Anmol, who's going to tell you a bit more about Starship.
Cool. Also, just to mention, Jake Hartnell is not here, who has been pivotal for getting this working. So, okay, we use Starship for getting this working, and so most of their work has been done by the Configure team. Again, we just converted their end-to-end, their system test to end-to-end test run against two chains. So we run like, the chain IDs are Mesh Osmosis 1, Mesh Juno 1, but they're actually running Mesh SDK chains, and we change some of the things to like look as if it's running like Osmosis and Juno. Once Osmosis and Juno are able to support, then Starship will, it's just a config change of the images, and then we can run it against actual chains. So what we do is we spin up multiple nodes for each of the chains. So we spin up 4. Again, it can go up to 30. Spin up a Hermes relayer, and then have the contracts run on both of them, so both become provider and consumer, and then have the front end connect to the back end, which is this. So what it ends up looking like is again similar to what Starship looks like. So there are multiple nodes here. We run again Explorer registry, the chain registry, and we do port forwarding. So everything is available locally, and then you can connect your front end or play around with it and do all these kind of things. And we also run it in the CI as well with just less number of resources. So yeah, that's about like Starship trying to get working with the contracts that already existed. Cool. Yeah, Joseph.
Thanks. Yeah, so let me tell you about the front end and the UX. So Mesh is chains with benefits. That's the tagline. And with the help of all of these amazing chains and their grants programs and everything, this essentially comes to fruition. And this is what it looks like. This is the Mesh. So we aggregate everything about your wallet and across all of Mesh to deliver you this experience. So we're not only showing the tokens that you've cross-staked across the Mesh, but also what you have staked on those chains and how you could benefit from the Mesh to increase your yield on those staking tokens. Let me run you through how the staking process works. We've prioritized having one point of entry for users to enter and exit the Mesh from any chain to any of the other Mesh chains. It starts with this modal right here. Instead of having a stake page and an unstake page and claiming pages, we make everything happen in one modal. You can scroll up to stake new tokens to the Mesh, and you can scroll down to unstake your current tokens from the Mesh. And we show all of the chains that you can stake to and how much APR you're getting because you decided to stake on the Mesh. We're also introducing a new concept we call validator squads. The idea is when you usually stake on a blockchain, you only select a few validators that you consider trustworthy and that you align values with. So instead of giving you that terrible experience of a list of 100 validators, we allow you to set very specific validators that you know are trustworthy, that you might stake to validator A or B on one occasion, or C and D on another. They'll appear in your validators, so it'll be easy for you to select the validators that you already know and that you're already used to. But of course, we also offer other validators so that you can enlarge your validator squad. Whenever you select a new validator out of the other validators lists, we add it to your validator squad as well. Now, let's Mesh. This is just an MVP, so it's a first look into how we want Mesh user experience to be. We're going to show you a lot more once it's closer to completion. So yeah, let's Mesh in Paris. Thanks.
Okay, so now is the time to announce the winners. Please welcome Simon, one of the judges.
Yeah, welcome. It's the time to announce the winners. Thank you very much for your patience, for your participation, for coming to Berlin, for CosmWasm. It's been amazing. The judges have sit together. We made some very, very tough decisions. It was hard. It was great teams here. The way this works now is we're going to announce the winners, the third one per team, then the second prize winners, and then the first prize winners. So I would like to get all the judges on stage because they are going to announce the winners for their tracks. Ooh, there's someone missing, and there's 3. It should be 4. Where's the Fincher judge? Here we go. Cool, I'll hand over the mic. We start with the third prize winners, and I will walk around, try to find the team. Please raise your hands if you want a prize, such that I can find you. Confio will be paying out the prizes over the course of the next 2 months. It's going to be summer vacation, so have a little bit of patience. We're going to pay in real money and figure out the bank details, how to make that happen. Looking forward. Yeah, you start with third prize, and then third, second, and so on.
Okay, for the OKP4 track, the third place goes to Yuno. Yuno.
Hi. For the Oral Network track, the NFT track, the third prize goes to the 2 people from Japan, Sushi Rolls. They come here all the way from Japan and start to learn CosmWasm, also learn the smart account abstractions and the figurant module as well to build their things.
In third place on the Neutron track, we decided to make a slight exception to some of the requirements of the challenge because the idea was just so cool and versatile, and we thought that if it is indeed deployed, we're going to learn a lot from it. A lot of people are going to want to use it, and so we decided to grant it to the Auth-Z access control project. Congratulations.
Okay, so sadly, we expected the DeFi project, which was our challenge, but there is no DeFi project in this hackathon. So yeah, we decided to skip first prize. Yeah, at this moment. Yeah, so yeah, it's okay.
All right.
Yeah.
All right. So. 1 second. Yeah.
So the teams are actually supposed to come on stage because that's better for the pictures.
Okay, so for the second place, for the KP4 track, for his great integration into the CI for the KP4 protocol, I'm calling on stage Starship.
Okay, for the second prize for Orange Work Track, there is a team from Abstract called the Olivote. So they got the thanks, Ida. They got a very weird idea about selling and bribing your vote through NFT. but yeah.
Thank you. And on the second slot, we have a project that generated a functioning application using a language that was made for testing initially, and then they just flipped the narrative. We found that very, very cool. Congratulations to CosmWasm. Good job, folks.
Oh yeah, so because of the same reason, yeah, which I mentioned, so we just pick a first over, so yeah, we also just skip second prize, yeah.
All right, so for the KP4 track, the winner is, in one word, prologue.
So for the NFT track, the first prize belongs to Dynamic NFT from Kinchugi validators. This is something that we in our network we want to do for a long time, where you can mint a box and then turn into NFT, and hopefully they can continue to make it specification, an official specification. Thanks.
Before I announce our first prize, I just wanted to give 2 honorable mentions to CrossFund and Neutron Shield for their work. If you want to turn your productions into real applications, like get in touch with me, we'll hook you up with the Neutrons grant program and help you refine this into something that you could bring to market. And with no further ado, let's announce the top winner of our track, which is the baddest of all projects, Bad Bridge. Congratulations.
So our first and last prize is for Korean Brown, which use our outstanding feature dialogue link. And yeah, it's not fully DeFi-oriented project, but there's some swap function in there. Yeah, so yeah, Korean Brown. Yeah.
Thank you very much, all the judges, for your great job. Okay. So I'm so happy this HackWasm turned out a very, very successful one with a very solid project, and looking forward to these awesome projects become, more product level for each chains. And yeah, I'm just so happy and excited what we're gonna see in the future, in the very near future. And now we're gonna do the closing by who? Father of CosmWasm, Ethan Fry.
Hello, hello. All right, thank you all. Thank you all for amazing projects. It was really, really impressive. I came by a little bit during the hacking, changed some ideas out here. And just seeing the presentations, just the number and the quality of projects out here, it was really, truly impressive. I haven't seen this in a long time. Possibly the first HackWasm where we were pitching. When it was like the first HackWasm, and everyone was basically, the first time they could launch on there, they're launching the first version of interchain accounts. The Kepler team was doing that. There's some people trying to build random number generation inside Tendermint. We brought CosmWasm. And since then, I've not seen nearly so many projects. But these are not just ideas. These are almost like, a month away from production. So it's really, really impressive here, just totally inspiring. And I wonder what is it? Maybe it's just because of the conference, because of the CosmWasm conference, and all the people that are attracted to it to come here. That's really like the synergy here. It was just amazing to see all these people coming and just like brainstorming over days and coming out here. That was really powerful. And maybe it was just this space, because this is the same space where I actually had that first CosmWasm back in 2019, HackAdam. And yeah, I think it's an amazing space. Thank you for organizing this. Thank you all the organizers for this place. I think everyone enjoyed it. And maybe it's the tooling we have already. The ideas and the tooling and the trainings we have. Because they say it takes a village to raise a child, but it takes an ecosystem to launch a dApp. And I think this is really true. It's not just one, but everyone, you see the collection, the collaboration, ideas from one team to another, the tools someone built for their chain go launch another chain, which build new tools to launch another chain. And I think over this, not just launching this platform, here's CosmWasm, here's some tools. We're building at Confia, but everyone else has built. The tools from like Osmosis, for example, have been great ones, and Cosmology, some DAO tooling. Lots of the tools from many different projects. The Stargaze NFT platform, this beautiful Aura, SG721. So this collaboration here is just amazing to see. So I think really it takes that. This whole ecosystem together is building the tools to make the better apps and better tools to build better apps and better tools. So now things that once were dreams can be hacked out in 48 hours. So really impressive to see all this stuff. Thank you all for coming. Thank you for contributing. And I'll see you next year.